an empirical formula is a formula that gives the simplest whole number ratio of atoms in a compound, while a molecular formula shows all of the atoms of each element in the molecule. Molecular formulas a lot of times can be reduced, but they're not. If you look at our examples for molecular formula, it says the molecular formula for benzene is C6H6. But you can reduce that down to CH because we can divide both of those numbers by 6. So if we look back at the example for empirical, it says the empirical formula for benzene is just CH. So an empirical formula is the reduced form of a molecular formula. So in this first one, it says, what's the empirical formula of propene? So you've got to figure out what that reduces down into. If you notice, 3 divides into both of those numbers, or both of those, and so we get CH2. Go ahead and pause the video and try the next 2 on your own. Glucose, if you look at it, we have 6 that goes into all of them, and so CH2O. For the last one, you had to first write your formula. Hexachlorine is 6 chlorines. Decabromide is 10 bromines. And 2 goes into both of those numbers. So we get Cl3Br5. So Cl3Br5. To solve an actual empirical formula, we're going to be given either grams, moles, or percent of each of the elements present. We're going to solve this problem going through our steps. It's the first example problem on your page. In this problem, we're given the percent of each element. We're going to assume that we have 100% all together. And so we're going to divide the percent of each of those elements by the atomic mass or molar mass of the element. Make sure that you have at least 4 significant figures. So 10.14% lithium, we're going to divide by 6.94. If they'd given us grams, we would have just taken the grams they gave us and divided it by 6.94. Grams divided by grams is going to give us our moles. So basically, we're just converting the grams they give us to moles. Our next element, nitrogen, 20.29%. So 20.29 grams of nitrogen divided by the molar mass of nitrogen. Notice it's just 14.01. We do not have to worry about diatomics with empirical problems because nitrogen's not by itself. It's in a compound with lithium and oxygen. Finally, oxygen, we have 69.57%. So 69.57 grams divided by 16 gives you 4.38 or 4.348. Step 2 says that you're going to divide these by the smallest answer that you got. So 1.461, or actually 1.448 is the smallest. So we're going to divide all of them by 1.448. At this point, if you get a whole number or something very close to a whole number, as in within a tenth, then you can round it to the nearest whole number. But if it's more than a tenth away, you cannot round it to the nearest whole number. Step 3 says, well, if you got all whole numbers, then those are your subscripts. And you just write your empirical formula. If you didn't get all whole numbers, then you're going to multiply to get a whole number, which we'll see in our next problem. So we get 1 lithium, 1 nitrogen, and 3 oxygens. So the steps were divide by molar mass, divide by smallest, multiply if necessary. Alright, so looking at this next problem, they gave us grams instead of percent. And we're looking for the empirical formula again. So I'm going to list out my elements. I have carbon, hydrogen, and oxygen. I have 94.74 grams of carbon, 21.05 grams of hydrogen, and 84.21 grams of oxygen. I'm going to divide by the molar mass. And then divide by smallest. If we compare these, oxygen has the smallest amount of 5.263. So remember that you have to divide all of them by that number. I get 1. For carbon, I get 1.5, and hydrogen, I get 4. Notice carbon is not a whole number, so I do have to leave it as 1.5. So I, in this case, have to multiply by some number to give me whole numbers. Well, if I multiply 1.5 by 2, I'm going to get a whole number. So I'm going to multiply all of them by 2, because what you do to one, you have to do to all of them. And now I'm done, because I have whole numbers. So C3H8O2. Notice I divided by molar mass, divided by the smallest, and then I multiplied if necessary. And your empirical formula should not be reduced. Had you multiplied by 4, you also would have got whole numbers, but your final answer could have been reduced down. Go ahead and pause the video and try this one on your own. Restart when you think you have it. So they gave you percents, so we're going to write those as grams, and in this problem we have four elements: carbon, hydrogen, oxygen, and nitrogen. Should divide it by the molar mass. So 12.01 for carbon, 1.01 for hydrogen, 16 for oxygen, and 14.01 for nitrogen. Now divide by smallest. If you compare those, oxygen should have been your smallest. Here we have two numbers that are not whole numbers, carbon and nitrogen. We can multiply it by 2, but that's only going to fix carbon, not nitrogen. While if we multiply by 4, it's going to fix both of them. So you could have multiplied by 2, but then you would have had to multiply by 2 again. But you would have wound up with the same answer. But had you realized that you could do 4, then you would have only had to multiply once. And 1.25 was more than a tenth away, so you could not round that down to just 1. So we get C10, H16, O4, N5. Go ahead and pause the video and try this one on your own. This one you should have gotten B, C6, H12, O5. If you didn't, you needed to list out your elements. Divide by molar mass. Divide by smallest, which in this case is oxygen. And in this case, we had 1.2, 2.4, and 1. So 1.2, or 0.2 is 1/5. So that tells me I need to multiply by 5. If you didn't realize that 0.2 is 1/5, then you could have been plugging in the calculator 1.2 times 2, 1.2 times 3, 1.2 times 4, 1.2 times 5 until you finally got a whole number. But it's quicker if you knew that 0.2 was 1/5. And so again, our answer is B, C6, H12, O5. To determine a molecular formula for a compound, we're going to do the example problem below. First, you need to find the molar mass of the empirical formula. If they don't give you the empirical formula, then you're going to have to calculate the empirical formula first. They gave us the empirical formula in this problem though, so we're just going to calculate that. We get CH2O, which is 30.03 grams per mole. Step 2, you're going to divide the given molar mass by the molar mass of the empirical formula. In this case, 240. So 240 over 30.03 gives you 8. In this case, you should get a whole number or something very close to a whole number. So then step 3 says multiply all of the subscripts by that whole number. And then write your molecular formula. So C8, H16, O8. Notice they have to have the same ratio of elements as the empirical does. This one is the same type of problem, but first you had to calculate the empirical because they didn't give you the empirical formula. You do know that it's a hydrocarbon, and they gave you the percent of carbon. So we know carbon is 92.3%, we need to find hydrogen. Because it's a hydrocarbon, it should have hydrogen and carbon. Our percents should add up to, if you said 100, you are correct. 100 minus 92.3 gives me my percent hydrogen, which is 7.7. Go ahead and pause the video and calculate the rest of the empirical on your own. So we divided by our molar mass, divide by smallest, which in this case is hydrogen, and so we get 1 carbon, 1 hydrogen. That's our empirical. So we need to find our empirical's molar mass. So adding up carbon and hydrogen, you get 13.01 or 13.02 grams per mole. Now we're going to use that 78. 78 over the empirical gives you 6. So I need to multiply that empirical by 6, giving you C6H6. Go ahead and pause the video and try this one on your own. Restart when you think you have it. You should have gotten E, not D. C20H14O4. If you did, you can fast forward. If not, then follow along. We had carbon, hydrogen, and oxygen. Divide those by their molar masses. You should get those values. Divide by smallest, which in this case is oxygen. We did not get whole numbers. We got a 0.5, so we multiply all of them by 2. And so we know our empirical is C10H7O2. Your empirical molar mass, you should have calculated as 159.17. And so the mass they gave you over 159.17 gives you 2. So you need to multiply the empirical formula by 2, giving you C20H14O4. So the answer is actually E, not D. Go ahead and pause the video and try this last one on your own. So this one was one of the easier ones to end with. You are given the empirical formula, so you didn't have to calculate that one. The answer is C. First thing you had to do was calculate the empirical's molar mass. So Cl2, or ClCH2, has a molar mass of 49.48. Take the mass they gave us, 98.96. So we take the mass they gave us, 98.96, put that over the molar mass of our empirical, 49.48, gives us 2, so we multiply our empirical by 2, and we get C.